All right, let's see if you remember those rules. Decide if these relations in the tables are functions or not. So number 22, is this a function or is it not a function? Well, if you said not a function, you are correct. The reason why it fails, there are multiple 2's and there are multiple zeros and multiple 4's. And by multiple, we have a pair there for each one. And so this one is not a function. All right, how about the second one? Is the second one a function or not? If you said yes, it's a function, you will be correct. This is a function. And I'll just put yes, a function. I should put yes, it is a function, but just for space, yes, a function. So this one is correct, and this one is not in terms of functions. And how about the last one, number 24? Is number 24 a function or not? If you said not, you are correct. This is not a function, and it fails because there are two x values there and two x values there that are the same. They are not unique. So this is not a function. All right, let's move on. How about this one here? This one wants us to, and this is from the textbook as well, use a mapping diagram to represent the relation. So let's just draw out what those mappings are. It will help to know what those points are, and I won't really have space, but just to get you the gist of what we're doing, that first point is -3 on the x-axis, and then -1. The second point there is -2, -1, and so forth. It would be hard to write them all in there. So if we just go ahead and write down what the x values are, and for our domain, we're going to put them in the first one. So we have our x values, -3. If I could get back to the pen. For our x values, we have negative, that's not the pen, that's a laser pointer. So we have -3, -2, right? That's -2. We have -1, right? That points at -1. Then we see a point here at 0. We see a point at +1, and then a point at +2. And we can just draw a little box there to represent our first mapping. All right, so now what we're going to do is get the range values. What are the range of values there? The range of values will be the y values. So for the first one, the range of values, we have three of them at -1. Sorry, not three. We have, yeah, three. So we have this one's at -1, this one's at -1, this one's at -1. And then we have this one at 0. This one here is at +1. This one here is at +2. And this one here is at +3 in the y. So that's our domain and our range. All right, so just going to erase this to take away. Okay, so now we just want to map them up. Remember, we had -3, 1. And you know what? I'm going to change the color so it stands out. All right, so starting with this one, let's go ahead and map those values. -3 is mapped to -1, as you see in the first point. The second point, that's -2, -1. And then the bottom point there, that's -1, -1. And then the x value at -1 is mapped to 0. Right, so these two here, we have two -1s. One is mapped to -1, and the other is mapped to 0. And then we have 0 mapped to 1. We have 1 mapped to 2, and then 2 mapped to 3. And is this one a function? Well, if you said no, it's not a function, you would be correct. And the reason why is two ways you can look at it. There are two arrows coming out of this one. I didn't draw the actual arrow points just because of the space on my laptop. But we have this one fails because of the two arrows, and it also fails because of the horizontal line test. All right, so that's how you could do number 26 and 27 if you try it in the book. But let's go ahead now and try number 30 and 232 from the book as well. This one's a little bit easier because all you need to do is use the vertical line test to determine whether or not this relation is a function. So if you took a straight line such as this and just try to drag it over, would it touch at 2 points? Well, right here you can see it would touch at these 2 points and multiple parts of the circle that would happen. And so this one would not be a function as it fails the vertical line test. And I'm just going to abbreviate it as not a function. How about this one, number 31? Would this one be a function? If you said yes, you are correct. This is a function because any line that you try to draw through there will only touch that graph at 1 point. And so we know that this one is a function. So I'm just going to put yes instead of writing out a lot. So this one is a function. All right, how about the last one, number 32? Is number 32 a function by using the vertical line test? If you said no, you were correct. You would see that here and here there are two x values that are being shared, and it happens at multiple parts on this, and so this one is not a function. Okay, so that's how we would do that. Just remember for this one, when you're doing the mapping diagrams, to make sure that you draw it neatly, as that will make it easier to see whether or not you have two arrows coming out. All right, for this last one here, we have example 4. And we're going to graph a function now. How do we go about graphing a function when just given an equation? Well, you should have learned some of these steps in Algebra 1. And what you do is you need to pick at least a negative, a zero, and a positive. The more values that you choose is the cleaner the line will look. And so we normally pick, when we draw a line, a linear equation or any equation, at least a negative, a zero, and a positive in terms of the x values. Remember, these represent your input. I'm going to choose negative 2, negative 1, 0, 1, and positive 2. Now you could technically choose anything. You could have negative 5 there, 0, 18, but 18 wouldn't work here. As you see, this graph does not allow for that. So you generally want to make sure that you choose values that will fit, in terms of the x values rather, x values that will fit between negative 5 and 5. So you don't want to go lower than negative 5 nor higher than positive 5. And so I chose values in between there. And remember, you want a negative, a 0, and a positive. So let's go ahead and try this one. If we substitute negative 2 into that equation, we have negative 2 plus 3, which, well, let me write it out. We have y is equal to negative 2. We substitute negative 2 into the x, plus 3, and this will equal to positive 1. And that will go in for our output. So we have the first point is negative 2, positive 1, which would be here. All right, and I'm using axis because using this touch screen, the points don't come out as nice. But whenever you do it, make sure you use a point, an actual point to draw it, and not axis. All right, so for the second one, we have y is equal to, we're substituting negative 1 in for x, plus 3, and that's going to give us 2. And so our second point would be at negative 1, positive 2, which is here. And then if we do the third one, we have substituting 0 in there, plus 3, right? Remember, we're substituting into this, is equal to 3. And so that means at 0, when x equals 0, when our input is 0, our output would be 3. And so that's 0, 3. Then we have y is equal to 1 plus 3. And so 1 plus 3 is 4. And so we have here, if we put that into the table, the 1, x equals 1, y equals 4, and so they meet right there. And then the last one, if we substitute that into the equation, we have 2 plus 3, and that will give us 5. And you might see a pattern here that each digit, if you go in the axis going in numerical order, consecutive order, you'll see that it's very easy to predict what the next y value would be. All right, so that's 5. You'll draw a nice straight line through there. It's kind of hard for me to use a ruler on this, so I'm just going to change the color and do my best to draw a straight line. So you draw a straight line through your points with an arrow on either side, and that represents that the line goes on forever in either direction, unless restricted by a domain or range. And we'll get to that in later chapters rather. All right, so now let's go ahead and do one more thing here. We just want to know about function notation. Remember, I talked about what function notation is. Here's an example of a linear function. And the reason why it's a linear function is because when you graph it, like what we just did in the previous example, it creates a line. And you see that in the prefix of linear. All right, and this is the general form, y equals to mx plus b, where m and b are constants. A constant just means a number. So it's a number times x plus a number. So by naming it function f, we can rewrite it into what we call the function notation. Now this is what you see very often in higher level maths versus using y. So just note that f of x, and that's how we say it, this is called f of x. You see here you could call it the value of f at x or f of x. Now just remember, it's another name for y, as I said, so you can use it interchangeably at times. But if they start off a question, if you're doing a question, somebody gives you a question and it has f of x, Keep it as f of x to just keep it consistent. All right, so the domain of function of the values of x are always defined, and the range of values is where the x in the domain of f gives you your output. And so substituting x values into the function is what gives you the output values or your range. All right, you can use other letters instead of f. You can have f of x, g of x as you see there. You can have h of x. Let's say you're doing a problem that deals with profit and you're using equations or functions. You can have the profit function or profit of x. If something costs something, you can use c and say c of x. And remember, for all of these, they can all be represented as y as well. And so just use interchangeably different notations that you can use. All right, so now let's do another substitution where we're going to substitute x equals negative 2 into the function. Now, generally, and sometimes you might see this as f of negative 2, meaning you're substituting the value of x in for x. Negative 2 in for x. And all you do is the same thing you've done in previous lessons of algebra and substitution, is wherever you see an x, simply substitute negative 2 in there, plus 3. And so that means our answer at x equals negative 2 is going to be positive 4 plus 3, which is 7. Over here, we can do the same thing, substitute negative 2 into the function, right? Now this is, we had normally we can have issues on this. A lot of students can have problems with substituting into an exponent, a variable with an exponent, and a negative. So remember, it's a negative, whatever the number is. The number we can represent as being in parentheses. And because the number is squared, the square goes on top of the parentheses. And then you could put the number in there, and the number you put in there is negative 2. And then you're going to use the order of operations to work that out. Subtract 4 times negative 2 plus 2. All right, so what we do next is, remember the order of operation is to do parentheses first. So you square the negative 2. And when you square the negative 2 in a calculator, make sure you put your parentheses. If you don't, you're going to get the wrong sign. So negative 2 times negative 2 is positive 2. But remember, this negative is still outside. And so although we get positive 2 here, when we put it into, once we get our answer, what I circled, it becomes positive 4 with that negative that's still on the outside. So you have to be very careful of those, as they can throw off a lot of students. Then the next one, negative 4 times negative 2, is going to be a positive there. And I don't have control of the pen. That's going to be positive 8 plus 2. Now we have negative 4 plus 8, which is going to give us positive 4. And then 4 plus 2 will give us 6. And those are our answers. All right, so now this is our last question for this lesson. And what we're going to do is utilize it in a real life situation. So, before we have already started how to create an equation. So imagine if you were given this question, you wrote it as an equation, you can rewrite it in terms of function notation form or using different variables. So for this one, we have a car has a 16-gallon gas tank. On a long trip, gas is used at a rate of about 2 gallons per hour. The gallons of gas, G, in the car's tank can be modeled by the equation G equals to 16 subtract 2t, where t is the time in hours. Identify the domain and range of the function, then graph the function. All right, so first of all, we need to decide what the domain and the range are, as it was stated. So for number 17, and this is from the book as well. So for number 17, first we need to know what our domain is. And our domain, remember, is the range of x values. Now this is not in x and y format. But because we know how equations work, then we know that our x here is going to be represented by the t. So t is going to represent our independent variable. And any question that deals with time, t will always be, or time will always be the independent variable. Time waits for no man, and so you can't have two sets of 1 hour, right? 1 hour passes, that's it. Time is gone. You can't get that time back. So that's one way you can always know. T will always be the independent variable, always be the input, or represent the x values. And so that obviously means that G is our y value. All right, so that's our domain. Now, domain also means all the possible x values. Now, since we're dealing with time, right, so our domain is going to be t. We also have to state all the types of values we can have for t. Can we have negative time? No, you can't go back in time. It would be nice if you could, but we can't. Remember, time waits for no man. So that means our time has to be greater than zero, right? It can't be zero. Now, in some questions, you could say greater than or equal to zero. In this case, we shall, because if you're not moving, that's 0 hours. I mean, if you haven't started the time yet, you're at 0 hours, and therefore your tank is full of gas. Now we have our range of values, and you could find that by substituting values in. So you could start with 0, and our range of values would be g. The y values, also known as the dependent variable, also known as our output, sorry. So our range of values is g, and what would that values be? Well, if we were to substitute values in there, you could use your understanding of inequalities as we learned previously and put 0 in there, and then 1 in there, and then 2 in there, right? 2 times 0 is 0, 16 subtract 2, that's will start to give you your values, right? And so you'll see that you start at 16, and then you're going to work your way down. Let's just give you an example. If I put 5 in there, 5 times 2 is 10, and 16 subtract 10 is 6. So what you see is as the t's increase, my values of g decrease. And so that means my g's will be less than or equal to 16. And so that's how we find our domain and our range of values. And so if we go ahead and do it wants us to graph first. So we graph. All right, so number 17, we're going to go ahead and create a table of values. And remember, our x is going to be t and our y's will be g. And so if we create a table of values, and we're going to start at our first domain, which is 0. We're not going to have any negative values because our t will not allow for that. So if you substitute 0 in there, I'm just trying to write some of them down here. 16 times 2 times 0 for that g is going to give us 16 minus 0, which is just 16. So that means our first point would be at 0, 16. And then if we were to keep on doing that, we moved over to 1. And I don't have room, but you should have room on your paper, on your notebook. So you have 16 subtract 2 times 1. And, okay, so I don't know what happened here. I somehow clicked something. And so I'm going to have to edit this or something. Let me go back into computer mode. Okay, so we have 16 minus 2, right? 2 times 1 is 2. 16 minus 2 is going to give us 14. And I have a different color there. So 16 minus 2 will give us 14. So that means at 1, when x is 1, we will get our y to be 14. And so you might start to see a pattern the more you do this. And I'm just going to say what that pattern is. You can go ahead and practice substituting to get each value. But as we move along on the t-axis, what you're seeing is that on the y-axis, we're going down by 2, right? We're losing 2 gallons per hour. So that's going to be 16, 14, 12, 10, 8, 6, and you're probably getting the picture. 4, 3, 2, 1. Sorry, I'm going the wrong way now. 5, 6, 7, 8, 9. That's what's supposed to be writing up top. 5, 6, 7. Right, so that goes down to 2. And then when we get to 8, you see that we finally hit 0. All right, so we can graph those points. We have 0, 16, 1, and 14. Now, if you look down bottom, always check your axes. This is 5 and this is 10. So that means this will be 4, 3, 2, 1. This would be 6, 7, 8, 9, 10. So be careful whenever you have a graph to make sure that you know what the numbers represent. So we have 1 and 14. You have 2 and 12. You have 3 and 10. You have 4 and 8. And you might see the pattern and you could possibly just fill them in as you go. But I'm just going to go through it point by point for the example. So 6 and 4, 7 and 2, 8 and 0. Right? And then you would just draw a line. I'm going to try to draw a line without a ruler. But make sure you use your ruler, as you can do that on paper. That was my best line I can do on touchscreen. All right, put your arrows through, and there you have a representation of the graph. And so you could see this represents our gas function, how gas is being consumed on our highway trip. 16 gallons, gas tank using 2 gallons per hour. It's just eating up gas. All right, so we see they ask a question now, number 18. It says, at the end of the trip, there are 2 gallons of gas left. How long was the trip? Well, remember, if it's 2 gallons of gas, you can use either the graph or the table. If we use the graph, G represents the gas. So if I go to 2, that's 2 gallons. And if I match it over to the graph and come down, I'll see that it's 7-hour trip. Another way I could do it is use the table. If I go onto G on the table, 2 on the table for 2 gallons left, we see that it's 7 hours as well. And so that's the connection. We can connect it using mapping diagrams. We can use the tables, the coordinate points, the graph, or even equations as we were substituting values as we are doing here.